Hello people, welcome one and all to Jojo's Learning Club.
Guys, I'm back again. So this is my lecture video on octal number systems. If you have not watched my video on binary number systems and decimal number systems, please do watch before this video. Then it would be greatly helpful for you to understand on octal number systems. So as I said, today I will be discussing on octal number systems. Octal number systems. So to write octal numbers, why we are using octal number systems? As we know that when we have to convert a decimal number to a binary number, it is a lengthy process, right? Because you have to repeatedly divide it by 2, and if it is a fraction, and you have to repeatedly multiply it by 2. So this is a lengthy process. So to convert a decimal number to a binary number, it would be easy if you convert first that binary number, decimal number to an octal number, and then it's very easy to write in terms of binary numbers. Okay, so let's understand what are octal numbers. Octal numbers are nothing but they are digits which are represented from 0 to 7. 0 to 7. So the numbers in between 0 to 7 are known as the octal numbers, and this table shows the representation of octal numbers to their binary numbers. So 0 is represented as 3 zeros, 1 is written in terms of 001, 2 is written as 010, 3 as 011, 4 as 100. How do you find it? It's same. For example, let's take the 7. Okay, let's divide it by 2. What do you get? 3. You get a remainder of 1, and what is 2? You get a you have 1, and so 1 1 1, that is 1 1 1. This is what shown in this table. So it would be better if you can always recollect this table, then it would be very easy for you to do calculations. So we have to find an octal number to a binary number. As I said, when you write an octal number in terms of binary numbers, you represent each number of an octal number in terms of 3 binary numbers. For example, 458, this is a binary number, octal number, right, with a base 8. So for octal number, they have 8 digits, that is from 0 to 7, and their radix or base is 8. So for an octal number 453, you can represent each number as 4 has 100, 5 has 101, and 3 has 011. So to write in terms of binary numbers, you have to just group it together. So 100, 101, 011, that's it. So it's very easy when you can convert a number from a decimal number to an octal number and then write in terms of binary numbers, because otherwise if you directly convert a decimal number to a binary number, then you will have a lot of calculation. That is, you have to repeatedly divide it by 2 until you get the remainder 1 or 0. Okay, so that's all about it. And now let's do some problems using octal numbers. So first, in this octal to decimal, before that please recollect that what did you do when you wanted to convert a binary number to a decimal? What did you do? With the power raised to the power of 2, you multiplied each numbers from starting from the from the right. You multiplied each number raised to their base power, right? So here we will do for what is the base of octal numbers? 8. So 4317, you can write in terms of, this is a this is a octal number. Binary numbers, when we convert it to a decimal number, we multiplied each numbers with their base raised to some power. Same here, to convert this octal number to the decimal number, we multiply each of these numbers to their base powers. For example, for 7, you can multiply it with 8 raised to 0. 1, you multiply it with 1 into 8 raised to 1. Again here 3 into 8 raised to 2. Here 4 into 8 raised to 3. So let's find it out. 7 into 8 raised to 0 is 11. Okay, 1 into 8 raised to 1, which is 8. Again 8 square is 16. 16 into 3 is 48. Okay, and 8 cube is 64 times 8, that is 512. 512 times 4 is 2048. So now let's add all these numbers together. 2048 plus 48 plus 15, right? So 8 is a 16, 16 plus 5, 21. So 10, 11. So the answer for this problem would be 2, 1, 1, 10. So that's all it. So how did you do this? I will recollect again as we did it for binary numbers to decimal numbers. When you want to convert any number system to the decimal number systems, you have to multiply each of their numbers with their starting from the least significant bit. You have to multiply each numbers to the raise to the base power until their most significant bit. For example, for the number 4317, the 7 is multiplied with 7 into 8 raised to 0, which is 7. Again 1 into 8 raised to 1, that is 8. 3 into 8 to the power of 2, which is 16. 16 times 8 square is 8 into 8. Sorry, here I did a mistake. That's what I was taking on. So 3 into 64, right? I did 8 into 2. It is 3 into 64. So 64 into 3 is 192, right? So it is 192. 3 into 64 is 192. So 2048 plus 192 plus 15, right? So 15, 1. Again here 13, 50. So 2255. So the answer for this problem would be 2255 base power of 10. I hope it's clear. I made a small mistake in between that I took 8 to the power 8 into 2. It's actually 8 to the power of 8. 8 to the power of 2, that is 8 into 8, 64. So you have to actually multiply 3 into 64. I did 3 into 16. That's why I made a small mistake over here. Yeah, so that's all about it. And this is how you do convert binary octal numbers to decimal numbers, same as in decimal numbers. Please don't get confused. It's very easy, right? And so we finished this both problems, right? And now to decimal to octal. Okay, recollect how did you do in binary numbers. So when you wanted to convert a decimal number to a binary number, you divided repeatedly by its base number. What was its base number? Base is actually 2, or the radix is 2. So you divided each number divided by 2. In the same way, you do it over here also. 493, here the radix is 8, so you divide it with 8. Okay, so 8 6 are 48. 8 6 are 48, and you have the remainder 1, and you have balance 5. Okay, here 8 7s are 56. 8 7s are 56, and you have 56, and you have remainder 5. So 493 to the base power of 8 you can convert in terms of octal number as. So to convert a decimal number to octal, you have to just divide each repeatedly by 8 until you get the smallest number, that is between 0 to 7. So here the value would be 7558. So this is the octal representation of this decimal number 493. I hope it's very much clear, right? Okay, so this is done. And again, there is another problem. So as I said, when you have a fraction, for decimals and binary numbers, for both numbers, if it is a fraction, to convert this number to a octal number. So this is a decimal number, right? Now we have to convert this number to octal number. So to convert a binary number to octal, after the fraction, you just constantly multiply it with 2. In the same way, now what you have to do here is, you have to constantly multiply it with 8 until you get a small value. Okay, so I'll show you an example. So here, to convert into octal fraction, first you have to convert it into 8. Let's see what is 4375 into 8. I can't do it. I don't remember it. So 8 times are 40. Again, 8 5s are 40. 4 is the remainder. 8 6 are 50. 56, 60, 0. 8 3s are 24, 30. Okay, 30. 8 3s are 24. 8 3s are 24, 30. 8 4s are 32. 4375 times 8, that is 3.5. You write it over here. So this is our first number, and take the rest of the decimal place after the number, that is 0.5. 0.5 times you again multiply it with 8, then you have 4.0. So 4 is the second number. So the equivalent number for this octal representation would be, first it is 0, okay? So we started with 0, right? There is 0, 0.34. You just have to pinpoint these numbers again. So 0.34. I'll explain you once again. When you wanted to convert a decimal number to an octal number, what you have to do is you have to constantly multiply with 8, okay? So you multiply with here with 8. Now here you got a number 0. So that's it, it's over. So until you get a 0, you have to multiply it with number 8. So you got here 8, 3.5. So my rest of the decimal place is 0.5. So again with that decimal fraction, again you have to multiply with 8. Now it is 4 and it is end. So here the decimal point is 0. So it is, now again you have to, after that you have to just start from the top to the down. The first number is 3 with the fraction. So you have to just write down the first fraction 3 and the next fraction. So the next number with the fraction is 4. So just write that 4 down. So the answer would be 0.34 to the base of 8. So to convert a decimal fraction to an octal fraction, you just have to multiply with 8. As you do to convert a number, decimal number to an octal number, what you do, you just divide it by 8 repeatedly until you get a final answer or a final digit with 0 or 0 to 7 as a balance. So this is same as decimal and binary number systems. So decimal and octal number systems, in decimal number systems you use the digits 0 to 9, in the binary number systems you use the digits 0 and 1, and in octal number systems you use the digits 0 to 7. So why we are using octal number systems? Because it is a tough process to write a decimal number to and binary number using dividing it by 2. So when we have an octal representation, first you could make this binary number, decimal number to a octal equivalent, and this octal equivalent, it's very easy. As you said, here we can just group and write in terms of binary numbers. So that's all for decimal to octal conversion. And now let's do decimal to binary. Why I am taking in this lecture is because in the last lecture I actually forgot to do an example using binary number systems with a fraction. So now we have the number 58.3125, right? So let's do it. I have to now clean the board. So now let's do for 58.3125. This is a decimal number and I want to find the equivalent binary number. So as to before the fractions, before the decimal point, these number you can just divide it by 2 and find it out. And now here it would be 29, 0, 2, 14, that is 1. Again here 7, 0, 2, 3, and the remainder is 1. Again 2, 1. So that's it, 1. So 1, so 29, 2, 29 is 0, again 2, 14, 1, 2, 7, and no remainder, 2, 3 and 1, remainder 2, 1 and remainder 1. So you can write this number as 1, 0 from here, 1, 1, 1, 0, 1, 0. So this is the binary number for this decimal number 58. But now we have to find for the fraction part 2. As I said, in binary octal numbers, when you have a fraction, then you have to multiply with 8. Sorry, with 2 over here. So you get 0.625. So this is the first number. And next, take again the decimal point, multiply it with 2. Then now you have 1.250. Okay, now take 0.250 and multiply it with 2. Now what you have? 0.50 here. Now check it, 0.50 times 2, what it is? 1.00. So you know that you have to calculate the fraction until you get the value over here as 0. So that's all you have to do. And now let's write the values 1. You have to, for the number systems we use from, you wrote it from down to top, and for the after the decimal fractions you have to write it from top to bottom. So 0, next number would be 1, sorry, first number is 0, the next number would be 1, the third number would be 0, again here it is 1. So you can put a point and write it as 0 1 0 1 to the base power of 2. So this is how you do calculate decimal numbers to a binary numbers or decimal numbers to octal numbers. The main use of octal numbers is to write easily the decimal numbers in terms of binary numbers. So now let me write an example for it. So the example would be 3714 divided by so we have written this problem. Now we have to convert in terms of binary numbers via octal. So via octal because it's much easier than doing it with 2. So 8 4s are 32. I have a remainder 1 51 8 6 are 48 34 8 for the 32 and I have a remainder 2. Again I have to multiply with 8. So 8 5s are 40, 8 8s are 64. I have a balance of 0 here. And again here 8 7s are 56 and I have a balance of 2. So as I said, to write this number you have to start like this. So 7 2 0 2. What is this? This is the octal representation of number 3714. 374 is with the base 10 and this is with the base 8. Now you want to convert this in terms of its binary numbers. So what you do, as I said, for each octal numbers you have 3 binary numbers. For 7 it is 1 1 1. For 2 it is 0 1 0. Yeah, 0 0 1 0 1 0. Here it is 0 0 0 and here it is 0 1 0. So just group it together. 1 1 1 0 1 0 0 0 0 0 1 0. So this is the binary number for this decimal number. So with this I finish my topic on octal numbers, and my next topic would be on hexadecimal, where I will again revise all the topics. So see you on my next video.